OK, now for some attacks. So now let's consider someone like Mallory, who is malicious, and let's think about what she might do. So you can try and predict what's about to happen. Sometimes people guess the attack ahead of time. So try and think of what happens if we follow the same process, but Mallory is malicious and wants to try and feed Alice some incorrect information. So as usual, Alice checks her cache to see if she knows the answer. If we assume the cache is empty, she doesn't know the answer, so she will broadcast a request, and she will ask everybody on the network if anyone knows the MAC address corresponding to 1.2.3.4. This is a broadcast request, so everybody receives it. Now, if you pause right here, we know that Bob is going to reply with the answer, but what could Mallory do if she's malicious? Try and think maliciously. So if Mallory is malicious, maybe she sends a fake answer, and she says, I am 1.2.3.4. Now, is that actually true? No, that's not Mallory's IP address, but she can lie and pretend like that's her and say, my MAC address is this really evil-looking MAC address, and we'll send this back to Alice. So Mallory hears the request and sends this malicious response before Bob's response can arrive. And then eventually Bob sends a response. Now, what happens at this point is if Alice hears this reply, she might be tempted to cache that reply, and now she thinks that when she wants to send messages to Bob, they should go to this malicious MAC address, and suddenly messages that were meant for Bob, they don't get sent to Bob anymore, they get sent to Mallory instead. So this is an example of an attack that Mallory can do. Now we can reflect on why this attack was possible. What were the preconditions that Mallory had to achieve to make this attack possible? And what are the consequences if Mallory succeeds at this attack? So here it is in text, but let's look at the pictures. So at this point, when Alice broadcasts the request, already one of the requirements for this attack to succeed is that Mallory has to be in the local network that Alice is in. So if I want to attack someone using this ARP attack, I need to be in the same network as the person I am attacking. If Mallory was somewhere far away, she would not hear this request and would not be able to send the response because she doesn't know when the request was made. So that's one precondition. Mallory has to be in the same local network as Alice. Now, another precondition for this attack to work is the fact that Mallory has to have her packet arrive before Bob. So if you're Mallory, your packet gets sent to Alice, but Bob is also going to produce and send a reply. So at this point, there's a race between Bob's legitimate answer and Mallory's malicious answer, and it has to be the case that Mallory's answer gets there first. Now, is that always going to happen? Maybe, maybe not. It depends on your threat model. But one of the conditions for this attack to work is that Mallory's answer has to get there first. And usually what happens at Alice's end is that she will accept the first answer. If you're Alice, you're not really expecting two people to answer, so you'll probably just accept whatever comes first. And in this case, if Mallory's answer comes first, that is what gets cached. So those are two of the preconditions that we need. And the third precondition, or I guess maybe more of a flaw that makes this attack possible, is the fact that Alice isn't checking the response in any way. So when Alice receives a response from someone, she accepts it as if it's fact. There is no cryptographic verification. There is no way to know if the answer is correct or if someone lied about something in the answer. So Alice accepts the answer without really checking it. So those are our preconditions. Mallory has to be in the same local network, and she has to win that race condition so that Mallory's answer gets there first. And because there's a flaw where Alice doesn't verify the response at all, we get something called ARP spoofing, which allows Mallory to carry out this attack. Now, what happens if this attack succeeds? So something else we can think about is what type of attacker Mallory was before this attack, and what type of attacker she is after executing this attack. So if we look at the steps of the attack, Mallory is only an on-path attacker before the attack happens. So before there's an attack, the only thing that Mallory has to do is hear this message and then send a malicious reply of her own. She didn't have to modify anyone else's messages. She was just an on-path attacker. But what happens after Mallory's attack succeeds? Well, now any packets that are meant for Bob are going to get sent to Mallory instead, where she could modify them or delete them before sending them to Bob. So Mallory has, in effect, upgraded herself from an on-path attacker to a man-in-the-middle attacker. That's what ARP spoofing can do to you. So before ARP spoofing, you're an on-path attacker. You can read the message that Alice broadcasts, but there's no way for you to modify any messages that she sends. But after the attack succeeds, now Alice is sending messages to Mallory, thinking that she's Bob, and Mallory is able to modify those messages before actually sending them over to Bob. So Mallory has upgraded herself from an on-path to a man-in-the-middle attacker. So those are the preconditions of ARP spoofing, and that's the result if you successfully execute the attack.